So the surface area of the covering here is given by, this is in form of a circle here. So you look at the covering here is in form of a circle like this, and this is area A2. So that area A2 is in form of a circle with a certain radius R. Okay, so here there is a certain radius R. So its formula is given by pi r what? Squared. That's the area of a circle, and it is the circle which is at the bottom. So it means that here you can factorize out pi r. So you have pi r out, and you have L plus r like that. So that is the total surface area of a cone that is what? That is covered at the bottom. That is the total surface area of a cone that is covered at the bottom. So I repeat, you have to get the area of the curved surface. So this is the curved surface. And also you get the area of the base, which is in form of a circle. So it is a circular base. Get those two areas and then add them together. In total, you get the area of the total surface area of a curved cone. Now, part B, what about the open what? The open cone. How do you get the surface area of the open cone? So here it is also the same thing. If you want to get the surface area of an open cone, so it means that now the bottom is not there. So the bottom is opened. So the only surface area that we are having in this case, which surface area is that we are having? If the bottom is opened, which surface area do you have now? Remember, which surface area do you have if this bottom is open? And this is our length L. Okay, so here it means that the only surface that we have is a what? A1. That is the only surface area that we have. Why? Because this part is what? Is opened. This part is opened. It is opened. There is nothing. So we only have this surface area. That. So to get the area of that cone, so the total surface area of that cone is equal to the area A1, and A1 is the area of the curved surface, and the area of the curved surface is given by pi r L. That's the area of the curved surface. So that gives us the total surface area of an opened what? Of an opened cone, whereas this is the total surface area of a covered what? Of a covered cone. So you should have some clear summary of that for the open it is this, and for the covered it is this. Okay, so now there were some questions that kept on following from that step there. For instance, if we look at let us look at this question which is here. So under that question, they are telling you to find, they are saying that the section of a circle is a section of a circle of radius 10 centimeters. A section of a circle of radius 10 centimeters. So that means that there is a circle in this form. Okay, just section of it, and this circle here has a radius of 10 centimeters. 10 centimeters. They are saying that having an angle of 100 degrees is bent to form a cone. So if this is the circle and we cut out part of it, we cut out part of it, we form what we call a cone. we form what we call a cone. So if we cut from here, somewhere like that, and we fold this part, we join part A, part B. If we remove this part here, if we remove this part is removed, and then we join A to B, what will happen is that we shall have a cone that is formed, like how I showed you last time. So if we join A to B, we shall have a cone that is formed. But they are saying that that cone is having an angle of 100 degrees. That section of a circle with of radius 10 degrees having an angle of 100 degrees is bent to form a what? Is bent to form a cone. And what are they asking for? They are telling us to find the length of the arc of the section. So if this is the angle here, because we have cut out this part, the part that I've shaded has been cut out. So that means that we remain with this part here. So this angle here is done, which is 100 degrees. The angle from here up to here is done, which is 100 degrees. So they're asking, what is the arc length from this side, moving from this side up to this side? This is what we call the arc length. That's what we call the arc length. What is the arc length that can form a cone of such a section? So it means that when we have a circle like this, and we have different parts, we have this part here, and we also have this part here. So whenever we create this section here, this one is called a sector. A sector comes from the word section. So this is a sector. And also this is a sector, this bigger one here. So the smaller one we have removed is what we call the minor sector. And then the big one that has remained, this one here, is what we call the major what? The major sector. So this is the major sector, this one here. This one here is the major sector, this one. And it is this sector that we are going to use to form what? To form a cone, this sector. So once we remove this part here and we join A to B, we shall form a cone. Now they're asking, what is this distance? How do you get to that distance? The length from this point, from A, moving this direction, up to what? Up to B. Whereby the angle of this section here is 100 degrees. 100 degrees. So this one takes us back where we have to determine what we call the arc what? The arc length. I don't know whether you remember how we get the arc length, but I don't know who's called Stuart, but arc length is given by the circumference of the whole circle. So it is given by, first of all, it is given by the circumference of the whole circle times the angle over 360. Or theta out of 360, then times the circumference of the whole circle. And the circumference of the whole circle is given by 2 pi what? 2 pi r, isn't it? Given by 2 pi what? 2 pi r. 2 pi r. Members, are we together? Are we together?
Yes.
Yes. So I wanted to draw for you to show you that cone, how it looks like practically, how it looks like. And I'm going to just cut it out from this piece of paper and show you. So let me cut out that circle there and then show you what they are doing. Okay. Know whether it has come out. So I don't know whether you can see that. So before that is our circle they are talking about, and that's the circle that forms a what? That forms a cone. That's the circle that is going to form a cone. Now, what you should know is that if this is the circle that forms a cone, and we have points, let me say from point, we have points. Let's say point A is here, and point B is here. Okay, so we create a section. So the section we are going to create is this one that we are going to remove from the center. We are going to remove this part. Okay, so this part, so this is the minor sector, and this is the major sector. This one is other side. So the angle of this section that is going to form our cone, this angle is 100 what? 100 degrees. So let me just remove. I'm going to remove this part here, this one. So let me just cut it out. Okay. So if I remove it out, and it comes out nicely. Okay, like that. So I've removed it out. Now, if I join A to B, I'll form what we call a cone. Okay, so this is a cone that is formed like this. If I join A to B, I form a cone, and that's the cone I've formed. Now, this cone that I've formed, you should know that this distance here was the radius. This is the radius here. Okay, that is the radius of the whole circle. And if I want to get the distance, the arc length this side, I have to use this formula. The theta, which is 100, so theta is 100 out of 360 times 2 pi r. 2 pi r is the circumference of the whole what? The whole circle. So the 100 will help me to get the circumference of only this what? Of only this part. So now you should know that when I do this and fold A will be together, what I will get a cone. And we say that the distance, this distance here from the tip to this part, this distance we call it as L. So this distance is L. It can be the radius of the circle, but if it changes into a cone, it becomes our distance what? Our distance L. So in this case here, where I'm going to put, where there is R, I'm going to put L, and I would say theta out of 360 times 2 pi L times 2 pi L. But remember that my L is equivalent to the radius. And when you look at this question, our radius was given as 10 what? That's 10 centimeters. That means that if I want to get the length of the arc, this is the length of the arc, this one here, length of arc, this distance from here. from here up to here, that is the distance of the, from there up to this distance. So I have to get this distance. So that distance is what we call the arc length. So now this time the arc length will be given by, arc length will be equal to, now the 100, which is the angle here, out of 360, then times 2, then times, I can set 22 out of 7, if they have not given you pi, 22 out of 7, then times the L, and our L is 10 centimeters. So from that case, we can be able to determine the length of the arc that can be used to get the cone. So we cancel this and this, and yeah, so we shall have, we cancel this once here, 18. So we can have by 2, 5, by 2, 9. So we shall have 5 times 22 times 10 out of 9 times 7. And Isaac, what do you get? You want to prove out whether it's 17 point that. So 5 times, do you get the same answer there? Members, do you get the same answer? You get 17 point what? 17 points. 17.46. That's what we get. We're getting 17.46. Why? Because maybe for them they used 3.14 and I've used 22 out of 7, but still the answer is correct, centimeters. And then the other thing is that determine the surface area of the cone. So they're asking us to determine the surface area of the cone. Now this cone is simply not covered. It is not covered. So this would be my cone. If I join it up, that would be my cone. I don't have glue. If I have glue, I can fix it here like this, and I'll form this cone like this. So now this is the length. Now what I need to do, they're asking me to find the surface area of this cone. And the surface area of this cone is only the area of the curved surface, area of the curved surface only. So how do I get the area of the curved surface? So the area of the curved surface of an open cone, I told you it is given by pi r L. That's the formula of the curved surface. So if the cone is not covered, so section of this is bent to form a cone. Okay, determine the surface area of a cone. So they are saying that the surface area of a cone is given by pi. This is what I started with. It's given by pi r L plus r. And we use this formula if you're looking at the surface area of a cone that is covered. So in this case, because now the question is not guiding us very well, telling us whether the cone is covered or it is not covered. So if the cone is not covered, then the surface area would be the total surface area. Yeah, would be given as the area of the curved surface, which is pi r L, then plus the area of the base, which is pi r squared, like that. So it is from this where they get the area, the total surface area of the cone, which is given as pi r into L plus r, something like that. So we factorize out pi r and pi r from here, and you have L plus r. Now, since we have our length L, so here it is just a matter of substitution. It is a matter of substitution. We have our L. L is the one which is which is 10, and then what is our R? Now we need to know what our R is and how do we find the R. Now, when you look at a cone, there's something that you should know is that if we are looking at this cone, we are going to look at two areas here. So this is the area we are talking about. This is the cone we are talking about. So now in this case, they have covered the cone. So if the cone is covered, we have to find this area. But this area here has got a radius R. And this is the length L that we are talking about. So don't forget that this curved surface here came from this. Okay, this is the curved surface. It came from this. So for us to get the area,
Using it for network.
Yes. So let us first find the area of the circle here, the area of the base. Area of the base, and the area of the base, and the area of the base is given by pi r squared. So this, members, are we together? Are you getting me? Are you getting me? Are you getting me? Cynthia, Esther, are you getting me? Esther, do you get me? Yes?
Yes.
Okay. So this is the base, and this is the curved surface. So the area of the base is in form of a circle. That's why here we have pi r squared in form of a circle. So for us to find the area of this circle here, we have to first find the radius. We have to first find the radius because we don't know this radius. We don't know this radius here. We don't know the radius. So what should we do? So what we are going to do is that I want to show you that this is the cone we are talking about. So here there is a radius which is here that we need to find that radius. So how do we find the radius? How do we find the radius? So the best thing that we are going to do is, one, we are going to use the circumference. Now, why do we use the circumference? You should know that this circumference that you are seeing, this arc length, this one here, this one here is the circumference of the cone. So if I curve it like this, you see it is forming this circular part, this one here. So that is the circumference of the base. If the cone is to sit, but if I'm to make this cone sit, if I'm to make it to sit down like this, sorry, if I make it to sit down like this, so it means that this one is the circumference of the base. This is the circumference of the base. But the circumference of the base is the same as the arc what? Is the same as this arc length, which we just found. So it means that our arc length, which we have just found, this one here, this arc length, it is equal to the circumference of the base. Circumference of the base. So there we should say that. There we should say that circumference of the base, circumference of base equals to the arc what? The arc length. So where we have now circumference of the base is given by 2 pi r and is equal to the arc length, which we got at 17.46. So from there we can get now the radius. The radius of the base. I don't know whether you are getting it, that if this is your cone, now we are looking at this. This one here is what I'm calling the circumference of the base, this distance here. Now we have to get that radius by using that. Okay, so this radius is the one which is here. So that radius will be 17.46 out of 2 pi. Out of 2 pi. So 17.46 divided by 2 pi. So 17.46 divided by 2 times 22 out of 7. That's what it means. That's what it means. So it means that there, what are we going to get? So 2 times, so 17.46 times 44 out of 7. So 44 out of 7. Okay. So we get 2.8 centimeters as our radius of the base. So we can now find the area of the base, this one here. So area of the base is known. We can find it and we can add it to the area of the curved surface. So area of the base is pi r plus area of the curved surface, which is pi r air, like that. So it means that here we shall have, this is pi r squared, so we shall have pi r into r plus air. Now, because our r is 2.8, so we shall have 22 out of 7 times 2.8 into 2.8 plus air, and our air is 10, like that. Okay, and then we shall have from there 22 out of 7 times 2.8 into, so here you get 8.8, then times 12.8. So you get 112.64. That's what I'm getting, 112.64. So there are changes in our answer because of the power we have used, which is 22 out of 7. But when you use 3.14, you get the same answer. You get the same answer. Okay. 8. So you get the same answer. You get the same answer if you use 3.14. All right. So that is the first question that you have. Now, there is this other question that is here before we go to this area of the frastrum. I think we can look at it in the second session, the frastrum. And with the frastrum, you have to know the area of the surface area of the whole cone, and also the surface area of like a small cone that may be put there. But let's just go through this question. We have 5 minutes. They're saying that there is a cone. There is a cone of radius 6 centimeters and height 8 centimeters. It's lit and laid out on a flat into a section of a cone. So there was a cone of base, this radius is this, and they have given you the height. It's lit and laid out flat into a section of a circle. Into a section of a circle. So it is cut. It was a cone like this, but now it was cut and then it formed a section of a circle. So that is the section of a circle. They're asking what angle does that section subtend at the center. So they're asking for this angle theta. Which angle does it subtend at the center? So at first what you have to do is we have to draw that cone. Initially, before opening up that cone, this is how the cone looked like. That's this cone. This cone had a radius of 6. The base had a radius of 6. Okay. So 6 centimeters. That was the base. And it had a height. This was the height of 8 centimeters. So they're asking, afterwards, this cone was now cut. Maybe they cut it and then it formed back. It was a cone like this, okay? Then afterwards, it was cut and it changed back into a section of a circle like that. So they're asking, what is the angle subtended at the center? They're asking for that angle that is subtended at the center. So what do we need to do? We need to first find this length here. You know now, this length, that arc length, is this one here, is the circumference of the base. This one. This one here is the circumference of the base. So we need to first find the circumference of the what? Of the base. And then also we find also the L. Find this L which is here. The length from the tip up to this part, we find it. So we can first find the length L, and later we can find the circumference of the base. Then we shall find the angle subtended at the center. So in case this lesson, this session ends, we'll come back and join. But we can first find this length L here, that which is here, using Pythagoras theorem. So in this Pythagoras theorem, then we are going to extract out a right angled triangle like that. So we have 8 centimeters, and here we have 6 centimeters, and we have 10. So we can first find L by saying that L squared equals to 8 squared plus 6 what? Squared. So our L squared equals to 64, then plus at what? At a 6. Then our L squared equals to 100. And if you find square root on both sides, it means that our L equals to 10 centimeters. So it is plus or minus 10, but our L shall be equal to 10 centimeters. Okay, so that is the length. So in the next session, when we come back, we shall look at how we can find the arc length here, which will be the distance from here up to there, so that we can find the unknown angle subtended at the center. And we also come with some questions. So come back. Okay? Is it okay?
Yes.
All right.